of image classification. But however, in order to obtain better image classification results, one more training phase to the two-phase approach is necessary. So that's our future work. Thank you very much.
Thank you for your presentation. It's really great work. So anyone have any questions? You can please ask now. Hello? No question. So if there's no question, we are moving to the last one. So the last paper is paying deep attention to both neighbors and multi-type task. So this is authors here and there's the university. So there's the outlines of the introduction and the proposed method and experiment, conclusion and future works. So for attention mechanism, explore a data points contextual information to enhance its representation for various learning problems by putting attention over the contextual data. So this multi-text learning consider several all learning problems instead of considering a single learning task. So recently, the attention mechanism has attracted much attention by the multitask learning problems. So Liu developed a multitask learning method to learn the task regarding attention of features. So proposed an attention neural network for multitask learning. This model is used to solve the problem of both discourse relationship, representation, and identification through two types of the representation. So Zhao designed a multitask learning which avoids using predefined task relations. And the attention mechanism has attracted much attention by the multitask learning problems. So then developed a method to solve the problem of the multitask learning of both answers, selection, and knowledge-based question answering. In this paper, we propose a narrow deep attention model. This model pays attention to data points, neighbors, and multiple texts. So the deep model is composed of multiple dual attention layers. Each dual attention layer is composed of a neighborhood attention layer and a task attention layer. So the deep model is composed of the multi-type dual attention layers. To train the model's parameters, we minimize the objective of the prediction errors and model complexity. So we compare the proposed method against the state of the art deep learning multitask models with an attention mechanism. So experiments show our method advantage and over the state of the art. This network structure, neighborhood and task to attention layers, attention layer over neighbors, attention layer over task, cognitions layer. This is input sample and the output the features. The attention layer over neighbors. In the neighborhood layer, we represent the input data point as an attention, combined of the input features of its neighboring data points. Attention layer over the task. So in the attention layer over task, we first convert the input feature to text-wise signatures by task-wise representation function, and then calculate the new task-wise feature by a weight combination of the task-wise features. Connection layer. This layer connected the outputs of the last two layers of attentions. So and the input vector of each data point as the input of the next layer. Multi-layer is a neural network. We built the multi-layer neural network of the dual attention of the neighbors and the task. So for the else layer, the processing is as follows. Training of the network parameters. To learn good quality of the predictor, we minimize the loss of the data points over the training set for all tasks. So where xk is the training set of the task, yik is the ground truth of the I data of the case task. So pure attention dataset is a video data set for task of the action recognition and the human post estimation. In this dataset, there are 2,000 videos captured for the sports pupil. So dataset is dataset of the face images. It has 2,000 face images which are selected from the celebrity face database. We have the multitask problems of the 22 binary classification problems and 5 regression problems. So dataset is a data collected from the Chinese online review website. So this is the website. The task is this data set to predict the review numbers, rating, quality score, environmental score, and the service score of each store, making it 5 task learning programs. The result comparison of other methods. So result compared to other methods from this figure, we can see that for all the case of the all data sets, so our proposed method outperforms the compared method of the method task learning based on attention mechanism. So in this figure, we can also see that a large value of the C can reduce the error. This indicates that a simple model is also beneficial for the predictions over the test set, since it can reduce the risk of the overfitting problem. This conclusion, in this paper, we proposed a narrow deep learning method for multitask learning problems. Our model is based on the dual attentions. So one attention is the neighbor's level and other one is at that level of the task. So the attention layer can explore both the neighborhood and the task attention and the relationship between them. So we design integration to learn the parameters of the model to reduce the training errors and the model complexity. So the experiment over benchmark data sets show that our model outperforms the state of the art deep learning models with an attention mechanism. Thank you, that's all. So anyone have any questions? Please ask.
I have a question. Yep, thank you.
Hello.
It's a very nice presentation.
Thank you.
Okay. So in order to bring the model to the production, always the size or the scale always matters. So maybe this is a very simple question, but I think it's very important for bringing it to production. How many layers in your model?
Okay, 7 layers.
Okay. And for in your experience, what software do you use to build the model?
I use the Keras and the TensorFlow.
Okay, thank you. Okay,
thank you.
Okay, I think we. Okay, thank you.
Thank you for your question.
Hello.
Hello.
I'm interested in your research direction. Can you tell me your email address so that I can ask you some question about your paper later?
Okay. My
Okay.
I will send you or I will send you later. It's okay when the meeting is finished.
Okay.
So can you tell me your name?
Okay. My name is Wang Zhonglie.
Wang Zhonglie. Okay.
Yeah, I will presentation at 11.
Okay. So it's finished. Thank you. So today's meeting is finished. Thank you all of you coming here today. Thank you. Hello. So thank you all of you. Bye bye.